I don't know what unit. Exponential logarithmic functions unit. I think it's unit number 5 or something like that. Okay, we're back to functions and transformations. Our equation, y equals a times b to the x, is going to be our parent function. So eventually we're going to be doing transformation. All right. Now, this is an exponential function where b is a positive number other than 1. Because if we had 1 there, we wouldn't have a function, right? 1 to the x is just 1. Yes, sir. Question. Yes, exponential function is a curved line because it is not a linear rate. Huh? Nope, it's the only curve. No, it's the only curve.
It curves on the y-axis?
Yes.
Or does it only?
Yes.
Like,
Hey, look at problems 1 and 2. Actually, quiet.
like that.
Actually, not in this class. Let's see. Yes, I think they can, but it's got to be opposite. Huh? Yeah, it's sideways.
Well, technically, but a parabola is going up and down.
It can go sideways, but you're not going to learn that until college algebra.
Oh.
All right, so looking at problems number 1 and 2. Just looking at the problems, and you determine, now this is the x-axis here. Here's the x-axis. Okay, here's the y-axis. And here's the y-axis. Can you just kind of make a good educated guess which one's growth and which one's decay? Good man.
I can read.
Hey, watch the language. So that means this one's decay. Now, here's the function. Y equals 1/2 3 to the x, and this function is y equals 3 to the 1/2 x. Now, in number 1, what's my a? 1/2. And what's my b? 3. Okay, my b is 3. X is the exponent.
To a unit in geometry.
Actually, I think this is the worksheet off of your Algebra 1 packet. Okay, what's my a in number 2? And what's my b? Now, here's growth. My a is 1/2. My b is 3. The b is the important part here. Can you tell me, looking at the b's, kind of a, huh? No. Okay, looking at the b's, can you make a generalization about the b's between growth and decay? Good. And it's not only a whole number, greater than 1. What about my b here? It's a fraction. It's less than 1, but greater than 0. Okay? So, here's the rules up here. Where a is greater than 1 and b is greater than 1, this is end behavior. Yes, ma'am. Yeah, one's going, if you read it left to right, one's going up That's growth. Decay is going down. Okay. All right. So we're going to be using our end behavior here as y increases. So as my y increases, as my y increases, my x increases. Okay. As y decreases, my x is also decreasing. Do you see that? Now, notice, shut up. Do you see my y equals 0 here? This is my x-axis. This is what, you notice that our graph never crosses y equals 0, right? Never does, never crosses that y equals 0. We call that an asymptote. In fact, it's a horizontal asymptote. It's a asymptote. Okay? Now, our asymptote can change when we have transformations. So keep an eye on that. Yes, y equals 0 is our asymptote for this particular problem. Now for our decay, notice that when our b is between 0 and 1, our y increases as x decreases. Okay? Remember our end behaviors? As x decreases, y goes to positive infinity. And generally, in our decay function here, as x increases, our y goes to what? Goes to 0, because this is our y equals 0 asymptote. Look at it left to right. If it's going up, growth. If it's going down, decay. Because we read left to right. Yes, it still would be growth and decay.
Down to the left.
Sure. All right, let's do a problem. The f of x equals 2 to the x. All right, what's my a?
3.
That's right, 1. What's my b? Because there's nothing there. Okay. My b is 2. So what kind of problem do I have here? I have a growth. And the rate of that growth is my a, which is 1. Because my b is greater than 1, my b is 2, so I know it's growth. And my a is 1, so that's great. Okay, are you ready to put this in your calculators?
If you don't like FDR, then
Yes, ma'am. Yes. I have 2 raised to the x. To the x, to the x, to the x, that's x. And there's my graph. Go to your table. Are you with me? 2 to the x. Graph it. To get that. Were you quiet down? Guys, quiet down. I can't. Somebody's got your calculator messed up. Okay, let's go to our chart. To get it, type in Q, caret key, see the caret key? Caret key, X. Okay, go to your chart. Okay, they want us to figure out some points here. They give us the X values, so the Y values for -3, 0.125, which is 1/8. -2, 0.25, so that's a quarter. -1 is 0.5, so that's a half. You see what's happening here? 0 is 1. Double 1 is 2. Double 2 is 4. Double 4 is... There you go. Hey, look at that. It's an exponent. All right, -3, 1/8. Okay, -2, 1/4. -1, 1/2. 0, 1. 1, 2. 2, 4. And 3, 8. By the way, this is going to be our parent function here. Because our b is greater than 1 and our a is 1. Okay, there's my graph.
We're going up the y-axis.
What's my y-intercept? What is across the y-axis? What's my domain? 2. In fact, all of our growth and decay problems are going to be negative infinity, positive infinity.
Are you there?
What's our range? What's our range?
Oh, right.
Remember, this is my y equals 0 axis.
That's going to be 0. No.
Yes.
Oh, okay.
Okay, this is my asymptote.
Asymptote?
Asymptote.
So it's going to be where the...
Or, as Chad would say, asymptote. Okay, so it's going to start at 0, but remember, it never crosses it or touches it. So I'm going to put a
bracket.
A parenthesis there. And where's it going to go? My y value. Infinity. My end behavior.
So for range, like it's going to be
end behavior. The f of x approaches blank. As no, because it never touches the x-axis. Nope. For this course, no, because we can shift these. There's going to be transformations. The range is going to change. Okay. All right. And the f of x approaches blank as x approaches positive infinity. Okay, as my x goes to the left, what happens to my y? Where does it go? Gets close to 0, but never crosses it. Good. What about when my x goes to the right? Way to go. This is all we're doing today. Okay, tomorrow we'll get into the transformations. Yes, it does. Well, it doesn't matter as long as the 0 matches infinity. Okay, you ready? Put 1/2 of the x in your calculators and graph it. I expect what kind of graph? Decay. Wonderful, because my B is 1/2. Yes. Otherwise, it's going to take the 2, raise it to the x, then divide. Okay? So decay, what's my A? Rate is 1. Y-intercept, well, we have to graph it first, right? Let's see, chart, -3, oh wait, did I do this right? Yeah. So -3, 8. -2 is going to be what? 4, half of 4 is 2, half of 2 is 1, half of 1 is half of 1/2, and half of a quarter. So, yep. Here's my A model. What's my y-intercept? What's my domain? What's my range? What's my lowest number? Never touches 0, but it's close, so parenthesis, and then it goes up to positive infinity. Got it? Okay. No, it really is, you should put the small one first. Yeah, because the next courses will mark off for that. Okay, the f of x approaches blank as x goes to the left, and the f of x approaches blank as x goes to the right.
Hold on, I have a question.
Can you wait like 10 seconds?
Yes.
As x goes to the left, my y of the graph goes to infinity. As my x goes to the right, my y value of the graph goes to 0. Question.
Possible for
Yes. It's spread out, yes. It would have to be a.
It has to be less.
Your A would have to be pretty large. Are you done? Good. All right. If you have colored pens, this next one's kind of cool.
No, I love.
Okay. So you're gonna. Okay. So in this one, my A is 1, my B is 2, my A is 2, my B is 2, my A is 5, my B is 2, my A is -1, my B is 2, my A is -3. So we're changing A here. And you're going to see what happens to each one of the graphs. Let's put them in all at the same time. Okay, 2 raised to the x, 2 times 2 raised to the x. I'm going to graph these two just to see what they look like. See what's happening when my whole number is getting bigger? Actually, it's making it skinnier, right? Stretching, yes, will be like a very small fraction that makes it y. Okay, 5 times 2 raised to the x. Oh, Oops. See how it's actually stretching it? So a whole number, the higher the whole number, higher the whole number, the a greater than 1, it actually doesn't have to be a whole number. Anything greater than 1, higher the number, stretches or skinnier or narrower, I think is what we used, wasn't it? Narrower the graph. So actually that goes under here. Okay, what if a is negative? So let's do the negative now. What do you think is going to happen? Wider, right? So let's try. I'm going to turn these off. And we'll do -1 times 2 raised to the x. -3 raised 2 times, or 2 to the x. And you know what? Let's make a really big one. Let's use -7 raised to the x. 2 raised to the x. I use -2. Hey, look at that. Not only did it get wider, it went upside down. Flips, reflects, however you want to call it. Mathematically, we're going to call it a reflect. It's not going to work. All right. Let's do number 5 real quick. I'm going to clear these out. And we'll put in 1/2 times 3 raised to the x. Let's get some numbers. -3 and 0.019, -2, 0.06, -1, 0.17, 0, 1/2, 1, 1.5, 2, 4.5, 3, 13.5. Let's graph this. So real close to the x-axis, a little less closer. 1/2, 1.5, 4.5, and 13.5.
Brendan?
He's not here today.
Brandon today.
Oh. Yes.
He's Mexican. The left.
Yeah, round up to 0.06. I just rounded it. Growth and decay. Y-intercept. 1.5, right?
No.
No.
3.
0.5. You're right. Yeah, 0.5.
Okay.
What else? Rate is 1/2. Domain. Range. Smallest number.
0.19.
0. Largest number.
Twice? 0. It's obviously 0.19.
No, it gets close to 0, but it's never going to reach 0. That's why I put it in parentheses. If it included 0, I would put a bracket there. Okay, the f of x approaches blank as x goes to the left, and the f of x goes to blank as x goes to the right. Okay, as x goes to the left, what happens to y of the graph?
Moves.
As x goes to the left, goes to 0. Good.
Okay. Go.
As x goes to the right, what happens to my y? Yep. All right, number 6. Number 6. I'm just going to ask one question about number 6. Is it growth or decay? Why? Yeah, it's a negative exponent. So my b, that's a negative exponent. So my b is not 4, it's 1/4. So it's decay. Okay. Questions, comments, concerns? You have some homework.
Yeah, well, that'd be. We do not have.
What is it, 3rd hour?
No, 4th hour. No.
Let's see, we assign this bookwork.
Okay, so we're doing.
Page 4, 39, 18, 22, 25, 34, and 36. That's all you have to do.
Oh, are we not doing?
We are, but that'll be tomorrow's homework.
Oh, okay. I agree. Do you not? Like my favorite movie. That is Tropic Thunder. I never. How dare you? I know. Robert Downey Jr. is the only white man. Black. Anyway.